Hey guys, welcome to the first video of this unit, and the first video is going to be on solving with radicals. So when solving with radicals, you do need to square both sides because you want to get rid of the radicals, and sometimes you'll actually have to square the terms twice. And then if you get two answers, you want to make sure that you check them both by plugging them in because chances are they won't both work. So sometimes they will, but a lot of times with these, they actually don't work. Okay, so if we're looking at the first example, like it says in the instructions, we're just going to square both sides to get rid of the radicals. And if we're squaring both sides, that's fine. So we have 4 times 2x plus 5, because we're squaring this 2 here, and we're squaring the term. So 4 times 2x plus 5 equals 20x minus 4. Okay, and then if we're solving for this, we just get 8x plus 20 equals 20x minus 4. And then we just get 24 equals 12x, x equals 2. And like I said, I always just plug them back in just to be safe. So we get 2 root, and then 2 times 2 is 4, plus 5, 2 root 9 is equal to root 20 times 2 is 40, minus 4 is 36. So we get 2 times 3 is equal to 6, and 6 does equal 6. So x minus 2 does work, and that's a correct solution. Okay, now we're going to look at another example where there are going to be two solutions, and this one's a little longer, so definitely write a little smaller if you're a big writer. So squared. Okay, so the left side is easy. We can just make this 3x plus 1. But on the right side, we do have two terms, so unfortunately we are going to have to FOIL, which is really annoying, but we're just going to do it. So we first get 3x minus 6, because if we write this out, you get root 3x minus 6 plus root x minus 4 times root 3x minus 6 plus root x minus 4. And so if we multiply the first terms together, we get 3x minus 6 because they're the same. And then if we multiply the second terms together, or the first term and the second term, I guess, we get plus root 3x squared, and then we get minus 18x plus 24, and then as you can see here, we actually do that again. So I'm just going to say we have 2 of those, and then if we multiply the last 2 together, we get plus x minus 4. So now if we combine this all, we get 3x plus 1 is equal to 4x minus 10 plus 2 root 3x squared minus 18x plus 24. So simplifying that, we just get negative x plus 11 is equal to this whole thing. So now we do have to square these terms again because we have another radical. So like I said, sometimes you're going to have to square both terms. And oftentimes when you have to square it twice, that's where you end up getting the two different answers. So if we FOIL the left side, we get x squared minus 22x plus 121. And if we FOIL the right side, we get 4, because we have to square the 2, times 3x squared minus 18x plus 24. Okay. So now at this point, we can start to combine things. So we have x squared minus 22x plus 121 is equal to 12x squared, and you might need a calculator for this, minus 72x plus 96. And then if we start bringing everything over to the right side, 0 equals 11x squared minus 50x minus 25. Okay, so now at this point, we're going to start FOILing, and it might look like a hard FOILing problem, but if you really do it, it's not that bad. So 0 equals 11x plus 5 times x minus 5, and so then you get x equals negative 5 elevenths, and x equals 5. So the x equals 5 looks pretty reliable. If we plug it in, we get root 16, because 3 times 5 is 15 plus 1 is 16, equals root 15 minus 6 is also root 9. Root 9 plus 5 minus 4 is 1, so plus root 1. So then you get 4 equals 3 plus 1, which is good. So that whole thing is fine, which is nice. But then if we look at our other term, this one seems a little bit more, okay, this might not be true. So just plugging this into the left-hand side, we get root 3 times negative 5 over 11 plus 1, which is going to equal root negative 15 over 11 plus 1, which is going to give us a negative number. So it's going to be root negative 4/11. And so we'll learn in the next video that this becomes imaginary. So this really isn't possible in this equation. So we're just going to cross this out. And so our only answer is going to be x equals 5. So like I said, if you get two answers, make sure to check them both by plugging them in, because chances are they both won't work. And then you can make sure that one of your answers is correct. Okay, so now we're going to be looking at solving with radicals and fractional exponents with something other than a power of 1/2. So when I say other than a power of 1/2, square root x is also equal to x to the power of 1/2. So we've been looking at stuff with only to the power of 1/2, but now we're going to be looking at stuff with other powers. So this is also equal to x plus 5 to the 1/4. So we're just going to raise both of these sides to the 4th power to get rid of this radical here. So we get x plus 5 equals 16, x equals 11. And so that's right. Okay, that's easy. And now we're going to look at two examples where you have to raise both sides and then you have to be careful of negatives. So our first example that we're going to look at is x to the 2/3 equals 4. So if we look at this example, we're going to raise both sides to the 3/2, so the reciprocal of the exponent on x, so that the exponents and x cancel out. So we get x equals 4 to the 3/2. So I usually like to do when I'm looking at stuff to the 3/2 and that kind of thing, is I usually like to make it like x equals 2 to the 2 squared to the power of 3/2, right? So you can also make this x equals the square root of 2 squared to the power of 3. And so both of these end up being x, so this over here ends up being x equals 2 to the 3rd, and this ends up being x equals the square root of 64. So looking at both of these cases, we can see that we're going to get the same thing, x equals 8. However, what we want to look for is we want to see if it's going to be negative or not. So if we look at this over here, x equals root 64. Whenever we take a square root of something, it becomes positive and negative. So we know that from basic algebra. So x equals positive or negative 8. So that's something that you might miss over here if you forget to take the positive and negative of a fractional exponent, which is something that I know I do a lot. So you definitely want to make sure that you're knowing if it's a negative or not. And what I usually like to do just to check to see if it is negative is I usually like to plug it back in. So let's take x equals negative 8. And if we have negative 8 to the 2/3, this also becomes the 3rd root of negative 8 squared. And negative 8 squared is also 64 because the negatives are going to cancel out. So then you get the 3rd root of 64, which also equals 4, which obviously works up here, right? And obviously the positive 8 is going to work. But now we're going to look at an example where the same thing does not happen. So if we look at the example, this is kind of the same thing, just a little bit the opposite. X to the 3/2 equals 8. So we're going to raise both of these powers to the 2/3, and then we get x equals 8 to the 2/3. So now if we look at this, we also get x equals 2 to the 3rd to the 2/3. So then we just get that x is equal to 2 squared, which equals 4. And if we try it the other way, x equals the 3rd root of 2 to the 3rd squared. We also get that this equals the x equals the 3rd root of 64, which equals 4, right? So now we have the same issue where we have to look at the positives and negatives. So as you should know by now, if you have a 3rd root, you don't have to take the positive and the negative because the 3rd root would account for the positive and the negative. So just to make sure that we don't have to, I'm going to put a positive and a negative here and just check it. So if we say we have negative 4 to the 3/2. If we raise, so if we do negative 4 to the 3rd and square root that, that is going to equal the square root of negative 64. But as we're going to learn in the next video, negative 64 is also equal to 8i, which is not equal to 8. So in this case, you can only have 4 be your final answer. And so this is definitely something that you need to remember, and probably the easiest way to remember this is if you have a 3 in the denominator. So if you're taking a cube root of something, it's going to either be positive or negative, not both. And if you have a square root, it's going to be both. But plugging it in is always a safe way to check your answer, and something that I always recommend. So I hope this is helpful, and next I would watch the imaginary numbers video if you're confused on that, and you should be fine for the test.